All right, Chapter 7, Lesson 1. Chapter 7 talks about congruence and similarity. So we're going to talk throughout the chapter exactly what those things mean. Sometimes they're congruent and similar. Sometimes they're just similar. So we'll talk about when they are what. All right, so first one, Lesson 1, talks about congruence and transformation. So transformations was all of Chapter 6. Remember the transformation. So we've got the translation, which is a slide. We've got the rotation, which is a turn, and we've got reflection, which is a flip. So sometimes you can do multiple translations to get a new shape. But whenever things are congruent, it means that they are the same size, same shape. So that would be something to add to your notes. They have to be the same size, same shape. They don't, however, have to be in the same orientation. What I mean by that would be like number 1. These are congruent, same size, same shape, although they are flipped and slid. So if you were to take B, AC, and if you were to take it and do a reflection and then slide it down, so even if you did a reflection, let's say over point C, so it would look something like this. Again, it's just a rough estimate. So if we take and do a reflection across that line right there, and then we slid it down and over, that's how you get the other one. So it is a reflection, just like they did right here. It is a reflection, and then they would slide each point down how many units and left how many ever units they decide. All right? So when they do that, again, just like we talked about yesterday, well, not necessarily yesterday, but it would be in 6.4, the last lesson that we did. You should be able to draw a line and match those vertices. Okay? So they are congruent because the reflection followed by a translation will put ABC onto ZYX. Okay. That being said, let's go on down here and see what we got. Maybe up just a little. Look at example 2. It says reflect the red figure over a vertical line. So if I reflect this over a vertical line, just an imaginary vertical line, this is what I've got. That's my mirror image. Now, does this look like this one? So even if you took it and moved it up, there's some key things here that I want you to look at. Even if you don't understand the whole reflecting, translating, whatever it is, look at it this way. This one has 2 units on the bottom. This one has 2 units on the bottom. They're both 4 units tall. This one's both 4 units tall. This one has one sticking out to the right of the third one down. This one has one sticking out to the right of the second one down. So therefore, it is not congruent. They do not match up exactly. It's close. That box right there is just in the wrong spot. So sometimes you can eyeball these things. So don't make it too incredibly difficult. Sometimes you can just look at these things. All right, let's try A and B under got it. So pause that and try that, please. All right, so A, if we look at that, they are congruent if you reflect it followed by a slide. So if I took A, reflected it over, let's say, that line right there, that would be a reflection, and then you could slide it down and over. All right, so that would be congruent. Next one, on B, if I took and turned it, let's say I took and rotated it counterclockwise to where it stood up, and you've got a box, 4 boxes this way, that would be the second one down would have an extra one out here. And then this one is not on this, but again, it's off here. Now, does that look like this one if I turned it? No. Why? Because this little box is on the wrong side. It's on an opposite side of that one. So B is not congruent. Okay. Again, sometimes you just got to use little tricks like that, and I'm all for that. Just look and see what parts match up and what parts don't. All right, determining the transformations. Again, a translation is a slide. It just means that you take and you pick up this line this AB and just slide it over. That's what we've got. A reflection is a flip. You flip it over. Just what it says. It's a reflection. Rotation just means that I would pick up or leave that point and turn it, maybe around like an imaginary point right there. Take this in and just turn the whole thing like you're turning a dial. So that would all turn that way. That is a rotation. So let's look at example 3. What does it say? Ms. Martinez created the logo shown. What transformations did she use if the letter D is the pre-image? So the D of Diamond Plumbing, D is the pre-image and the letter P is the image. So that's where it ends up. Are the two figures congruent? Okay, so what would they do? And it even shows you right there, if you take the D and rotate it 180 degrees, that's what you've got. The D becomes a P. D becomes a P, and then you would just have to take and translate that unit. You would just have to slide it up. Slide it up. So they are congruent because one would rotate around and slide up right into that position. So if you could think about even about breaking these pieces apart, taking the D, switching it upside down, and then moving it straight up, that's what you would have. So they are congruent because they're the exact same size and they would go into the exact same position. So under got it, looking at that one, we'll just do that one together. What transformations could be used if the letter W is the pre-image? So this is the pre-image and you want to get it to be the letter M. What would you have to do? Well, if you're going to turn it upside down, you're going to turn, you could rotate it and then slide it up. Couldn't you also flip it, let's say, over, rotate it, sorry, reflect it over this imaginary line, which would give you something that looks like this? And then could you not flip it then again this way? Flip it up and down and then maybe slide it down? That could be one. That's an answer. A completely separate answer, you could say that you could rotate this around, rotate that around, and then translate it down. Whatever you want to do. There are multiple answers to this. Multiple answers. As long as they make sense, I'd say you're good. As long as you're not saying, okay, I would just translate it to the left. No, you also either have to rotate it or flip it. All right? So really, this one is open to interpretation. There are multiple ways of doing it. You have 3 things to pick from: translation, rotation, and a reflection. So as long as those work for you, you need to tell me if they are congruent or not. So really quickly, let's just talk about, since we got a little bit of extra time on this one, under guided practice, determine if the two figures are congruent by using transformations and explain your reasoning. So number 1, they are congruent because if you were to rotate one and slide it over, or you could even flip this top one, flip it down, and then slide it up and over, that would also give it to you. Number 2, those are congruent. Again, on this one, I would just look and say, okay, 1, 2, 3, 4 units with an extra unit on the second from the end. If I took and rotated this one down, I would have 1, 2, 3, 4 units long ways, an extra one on top of that. So whichever way you want to do it is fine with me. Last one, number 3. The Boyd Box Company uses the logo shown. What transformations could be used if the red trapezoid is the pre-image and the blue trapezoid is the image? What are you doing there? So you basically have this shape. Can't really see the corner of that. That's what makes it a trapezoid. So you've got that one, and you're making it to be that one. What could you do? You could rotate this one around, slide it down into the position. You could, well, if you flipped it, you'd have to flip it twice, because if you flipped this one, let's say over, let's say that line right there, you're going to end up with something that looks like this. What's wrong with that? Well, it's got the longer side on this one. So you then would have to flip it again let's say over a line that goes down this way. Flip it again and slide it into place. So to me on that one, the easiest one would just be to rotate this around, rotate that around, and then slide it into place. Okay, so again, multiple answers. Just make sure yours makes sense. Shouldn't have much problems on this, but if you do, come see me. Good luck.